Meet Roger Lewis, founder of BuzzCloud and inventor of iBuzzHive, a smart beehive for urban rooftop. His startup has received pre-seed funding of $100,000 from a hardware accelerator in Hong Kong. He is currently in Shenzhen to manufacture his device. However, since the pandemic, he has also focused on items such as personal protective equipment like face masks. In this interview, he will talk about the global food problems that we will all soon face, his quest to make the world more sustainable, and his experience in navigating the Chinese manufacturing scene. Let's see how we can save our food supply one beehive at a time. Mac or PC?
Mac.
iPhone or Android?
Android.
Okay, tea or coffee?
Coffee.
WhatsApp or WeChat?
Both.
That's a good answer.
Must I make a choice? Then I'd go for WeChat.
Because you're in Shenzhen right now, right?
Oh, yeah.
Can you spend some time and talk about your background?
Yeah, sure. Well, I was born in Cape Town, South Africa, so that's a long way and a long time ago. I did my education in and around southern African countries. My parents moved about 4 or 5 times, and that gave me the travel bug. By the time I was late teens, I was actually still at school, but working at postgrad level because I taught myself electronics as a hobby. And by the time I had finished my first stint at full-time employment, I worked for 5 years for the telco in South Africa. All these major countries have their own individual. Back then it was state-owned telcos. They've all been privatized about 20 or 30 years ago. So this was still when it was a government organization, and I ended up working in their laboratory. A telco is a telecommunication company.
Oh, okay. There you go.
So they used to do telephones and stamps and letters and delivery of mail, but then they cut themselves into two, and the mail delivery and stamps became the general post office. And then they all became telcos when the telephone network acquired a global scale. So 30 or 40 years ago, you could pick up a telephone anywhere on the planet pretty much, dial in a number and have a conversation. And it was designed specifically with quality of service to enable that to happen. And it still works pretty well in spite of it being really, really old technology. So in your life, in my life, we've seen the telephone network come in and almost go. It hasn't quite gone yet. But we've certainly seen the internet as the second major global network that has acquired global reach and global scale. And of course, you can do so much more on the internet than on a telephone. A telephone could only do voice, that was it. And a trickle of data, such an insignificant trickle of data. 64 kilobits, which in today's world, it's not even relevant. It's completely irrelevant, the amount of data you can do over the telephone network. So I was working as an engineer for the telco laboratories, and across the world, almost every telco, so British Telecom, or Deutsche Telekom in Germany, or France Telecom in France, they all have their little department where they like to do a bit of research and development. It's the opposite of blue sky research and development. So I'm not sure if blue sky is essentially where you've got enough money that you pay a bunch of engineers to sit down and they basically sit and think. And they're taught to think, what if we combine this with that? And is there maybe we can make a product like that? And then they go in and work out and see if they can productize any of those really freewheeling it's called blue sky R&D. Telco R&D is exactly the opposite end of the spectrum, where the telco tells you, here is a piece of equipment. We got it from a supplier in China. Take it apart and copy it and tell us the circuit diagram and tell us the listing and disassemble it. Tell us everything. Give us a printed circuit board layout, schematic and everything. So I did a number of those. That got to where it was really quite boring. And then I got lucky because I was skilled at it, and having had a hobby as electronics for many, many years before I started working. So it came naturally, and I was doing basically my hobby and getting paid. And life doesn't get a lot sweeter than that. I've always striven to get into that sort of circumstance where I'm enjoying my work and it's making money, making a living for me, and providing funds for me to do interesting things with my family and my children. So that to me is important. I'm passionate about doing things that I enjoy doing. And over the decades, the things that I enjoy doing have changed. I'm now running a startup which is based in Hong Kong. We gained some pre-seed capital from an IoT accelerator program that was running in Hong Kong at that point in time. Although it was very expensive and the sales was really absolutely remarkable. At the end of the day, when I was finished, I was quite capable of making every single mistake that I had not been warned about. So when it came to doing production in China, I've now learned the hard way how to leverage commoditized production in China and how to get it right. Not only so that you make money, but also so that you don't risk your IP. Because everybody knows, you come to Shenzhen, there are copycats. There are people who will, without a blink of an eye, they will copy your intellectual property. So rule number 1, don't disclose intellectual property to anybody who manufactures anything for you. That's it. If you break that rule, well, good luck. Not a sensible thing to do. So there are these rules which I've crafted in the last, I've only been across in this part of the world 14 months, 15 months. And I've crafted a number of rules, and I'm finding a number of startups that are in Shenzhen from abroad, and they are making all the same mistakes I make. So they go to a factory and they say, here's my baby, can you make my baby my product? Can you make my product for me? And of course, the factory can only say one thing. Yes, of course we can. This is what we do. We're a production house. Of course. What is it? Show us. So you pull out the circuit diagrams, you pull out the software listings, you pull out the mechanical CAD drawings, and within a week or two, they know everything they need to know to make your product. But there's no constraint on them. They can make it for you, in which case you make some money, or they can also make it for themselves, in which it happens on a regular basis. So in that nightmare scenario, you wake up one day and you look at Taobao, and you see your baby for sale on Taobao. It's not your brand, but it's your design. Then you know, you've learned the hard way. You should not have disclosed your IP because this is going to happen. But it's not that the Chinese people are any more dishonest than anybody else in the world. Exactly the opposite. I've come to love the Chinese people. I love the culture. I love the way they work. I love what they do. So much so I'm busy learning Mandarin, which I didn't think, that wasn't my plan originally. But having been through COVID and the lockdown here just north of Shenzhen, I saw people like I've never seen anywhere else, and I've traveled reasonably broadly. The Chinese people to me are absolutely awesome. I love what they do. So it's just a matter of respecting the boundaries, not being an absolute idiot and spilling out all your intellectual property and expecting the other side to say, oh, well, that's actually not our IP. If you're stupid enough to spill out your IP without any protection, and basically an NDA is worth nothing here unless it's in Chinese language and subject to Chinese law. And people don't know this. People write up an English NDA. That tells the factory manager one thing. You don't know what you're doing. So what's he going to do? He's going to help himself to your intellectual property wholesale, hand over fist, because you've enabled him to do that. So these are some of the things that I've learned. When I was a whole lot younger, I had an opportunity where I'd learned analog electronics at the local library in the place where I was living. So 1 or 2 mile walk to the library. I scoured all the books, learned analog electronics. There was no digital electronics that hadn't come around yet. In the early 70s, I realized that digital electronics was now available. I could actually go to a shop and buy 7.4 series logic chips, quad NAND gate or an exclusive OR gate, and counters and BCD decoders and so forth. And I thought, well, what can I do with this? And then I thought, actually, I've got this really old alarm clock that I've got to wind up each night, and it goes click, clock, click, clock, click, clock, click, clock all night. Can't stand the noise. Why don't I make a digital clock? And so I did. This was about 10, 15 years before you could buy them over the counter. Built the digital clock, and I also learned some very important lessons about getting the scope of any work that you do right at the beginning. I didn't know about scope creep. I learned scope creep with my crystal control digital clock. So what happened is I got the clock going, and then I realized, well, actually I wanted to have the alarm feature, and that was almost double the amount of work. The only thing I didn't have to make 2 of was the power supply. The power supply was beefy enough to carry the extra logic boards that I put in. So it took a lot longer than expected. And eventually on a day I got it working, and it was more accurate, being crystal controlled. It was more accurate than any of the watches or clocks that I had access to in probably a 500-mile radius. So the only thing I could do to test the accuracy was to use a shortwave receiver. And I used to tune in once a month, into shortwave transmissions from Rugby, a town called Rugby in England. And they had a huge radio transmitter, and they used to transmit the time in Morse code. And you used to go boop, 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 boop. And on the boop, that was 6 o'clock or 7 o'clock or 8 o'clock or whatever the Morse code said. And when it said pip, I hit the switch, and for another month, when it got down, it was more accurate than a second in a month. I kind of lost interest in doing it because I knew what the accuracy was. I knew the next step to make it more accurate was to build a temperature-controlled oven, and I just had no desire to do that. So I just left it like that, and every couple of months I'd correct it because it was 1 or 2 seconds out, and that was more accurate than anything that I had.
Yeah, that's pretty accurate.
Yeah. But we now know crystal watches and clocks are dirt cheap, and they are pretty accurate.
Yeah.
They only use a crystal today. We use a crystal of either 16 kilohertz or 32 kilohertz. Those are two popular frequencies. The crystal I used was at 1 megahertz. It turns out that was a design mistake because I was a newbie. I should have used a lower frequency and paid more attention to the quality of the crystal, or the drift, which is measured in parts per million, or ppm. Back then, this is a long time ago, I think it was a 100 ppm crystal, and that translated to about a second a month of lost time or gained time, which wasn't too bad. So moved on from that. That taught me that I was still at school when I finished with that. So I had a good grounding in digital logic and Boolean mathematics that goes with that. This is not difficult stuff for anybody. If you've been to college and you've done anything with computer science, you will have nailed Boolean logic and a bit of math in connection with that. So that's pretty straightforward stuff. But for me, I've always taken an interest academically in things where I can see and indeed feel a very real application. So if you ask me to design something that hasn't got a real life application, you're not going to get my attention. I'm going to lose interest in that so rapidly. But if I can see, if we do this, that's how you'd actually implement it, and this is what it'll do for me and everybody else on the planet.
Now that you understand the founder and his passion for engineering, you will learn about the problem that he's trying to solve, and that deserves another video. To paint you a picture, right after interviewing Roger, I've immediately signed up to help out at a food tech hackathon.